In this video, we're going to add, subtract, and multiply polynomials. And I think the best way to do this is just to kind of roll through a few examples and practice. So here we go. Let's get started with the first example. We'll start off with addition. Let's add the following. We're going to add the polynomial x to the fourth plus 2x cubed plus 8 to the polynomial 2x to the fourth minus 9. Guys, all you really need to do is add like terms. Very important that you recognize that there's a plus sign here. We're not multiplying these polynomials. We'll do that soon enough. All we want to do is find like terms. Now remember, like terms have the same variable part. So I have an x to the fourth here, and I also have an x to the fourth here. There's 1 plus 2. I have 3 x to the fourths. What I like to do is sometimes cross them out when I'm done. I have an x cubed term. But I don't believe I have any other x cubed terms, so that one just stays positive 2x cubed. Then I have a 8 to add with the negative 9. Those are my constant terms, and 8 minus 9 is minus 1. I think I covered every single term that I can possibly add, and also notice my final answer is written in standard form from highest to lowest exponents, and we're finished. Let's look at another example where we're going to subtract. Now, subtraction we can make into an addition problem pretty easily, and I'll just write this down first. We have 9x squared, or excuse me, 9x to the fourth rather, minus 12x to the third, plus x squared minus 8, and we're going to subtract from that the polynomial 3x to the fourth minus 12x cubes minus x. So when you're subtracting two polynomials, what I like to do is kind of like when we're subtracting complex numbers, or if you're just even subtracting any two terms, is distribute the negative. So I'm going to rewrite this as a 9x to the fourth minus 12x cubed plus x squared minus 8, and if we distribute the negative, it becomes negative 3x to the fourth. Negative times a negative 12 makes a positive 12x cubes, and then negative times a negative x is positive x. So let's add up the like terms. If I take a look, I have a x to the fourth, and 9 minus 3 makes 6x to the fourths. If we go for another new term, let's see if we can find any other x cubes. I have a negative 12x cubed, and I have a positive 12x cubed. So in all, the negative 12 plus 12x cubes, that's kind of nice. Those just go away for me. I don't have to worry about them. You know what I also should do? I'm going to go ahead and cross these out. I don't want to get confused with the terms I've already added. Now I'm going to take a look at, let's see if I have any x squareds. I have an x squared there. Unfortunately, there's no other x squareds, so it's just going to be positive x squared. Cross that guy out. And now I have an 8, but there's no other constant term. I'm going to write minus 8, cancel that out. Now as I look across, I have everything except for, I never took care of that positive x. There's nothing to add that positive x to. So I'm done except for, I don't like the way I have that written. I don't have it in standard form. Let's write it from highest to lowest exponent, where the constant term is at the end. That would probably be the best way to write that guy. So that's subtracting. Let's move on to some multiplication problems. This is where it gets a little bit more fun. Let's call this one, let's call this one example. We're really on example 3. We're going to multiply a few different types here. I'm going to multiply the binomial x plus 2, the two-term polynomial, to the trinomial, this quadratic trinomial 5x squared plus 3x minus 1. Now what I like to do is just essentially multiply every term of the first binomial, or in this case binomial, to the second polynomial. So I try to keep track of it by drawing these arcs. So I'm going to multiply this x to the 5x squared, and I get 5x to the third. There's really 3 factors of x if I multiply. Now I'm going to do x times 3x. That's going to be a positive 3x to the second. If I multiply x times negative 1, I'll get minus x. And I've just multiplied that term x to every other term of that second polynomial. So I'm finished with the x. Now I'm going to go ahead and multiply my 2 to everything in this second polynomial. I'm going to do 2 times 5x squared. That's going to be a positive 10x squared. Do 2 times positive 3x. That's going to be a positive 6x. And then 2 times negative 1 is just negative 2. Now we're playing the game where we're going to try to add up the like terms. Let's see if we have any like terms. I only have one x cubed term, and it's 5x cubed, so there's nothing to add that up with. I have a 3x squared and a 10x squared. If I add those, I get a positive 13x squareds. Cancel those out. I have a negative x plus 6x. That's going to be a positive 5x. Cancel those out. And my constant is minus 2. So we've just multiplied together the binomial and the trinomial and got this cubic polynomial. It's now a degree 3, which kind of makes sense. I multiplied a degree 1 x times a quadratic x squared, and x times x squared makes x cubed. That's going to tell you what the degree is. Let's look at another couple of examples of multiplying. There's a few different types to kind of be ready for here. So let's look at this one. Example 4, still multiplying. Let's do this. Let's do x minus 2, x minus 1, and an x plus 3. I have these 3 binomials that I have to multiply. Now it would be nice to be able to just multiply them all together at once, but basically the plan of attack is going to be, hey, let's just concentrate on these guys here first, and let's FOIL them together. So really what we've done in chapter 5, I'm going to do x times x to get x squared, then an x times negative 1 to get minus x. Inside we get a minus 2x, and then last terms multiply to make positive 2. Now, before I multiply that to the x plus 3, right, there's still the x plus 3 we have to multiply to. I'm going to add up the like terms so it's not as tricky. So it's going to become x squared minus 3x plus 2, and I'm going to multiply that to the x plus 3. This is kind of like the example we started with in example 3, right next to it. But it's a little different order, and that's fine. I'm going to start off by multiplying my x squared. Let's use a different color just to make it fun. I'm going to start off by multiplying my x squared times everything in the binomial x plus 3. So I'm going to do x squared times x. That's x cubed. I'm going to do x squared times 3. That's positive 3x squared. I've just multiplied the x squared to everything, so I'm going to cross that guy out. Let's use a different color for the negative 3x. I'm going to do negative 3x times x. That's minus 3x squared. I'm going to do minus 3x times 3. That's going to be minus 9x. Let's use a different color yet. Let's use a blue. I'm going to use 2 now times the x. That's a plus 2x. And a 2 times a 3 is plus 6. So we now just have to go ahead and add up all the like terms. Let's see if we have anything to add to the x cubed. Nope. So I'm just going to copy down x cubed. 3x squared minus 3x squared, that's kind of convenient. They cancel. Negative 9x plus 2x are like terms. I get negative 7x. Those are now done, and I'm left with a plus 6. So that is my result. I have this cubic polynomial. Actually, it's a cubic trinomial, right? 3 terms there. I think there's only 2 other examples that we're going to take a look at, and we're going to try to squeeze them in here. Let's do example 5. I'm going to try to multiply 5a minus 2 squared out. Now, technically, I'm not going to show you anything new here. If you have a binomial squared, you know that really means 5a minus 2 is a product of itself. And there's 2 factors there. You really just have to FOIL this out. 5a times 5a is 25a squared. You're going to get a 5a times negative 2, a negative 10a. And in the middle, another negative 10a. And then negative 2 times negative 2 makes positive 4. If you add the like terms, you're going to get 25a squared minus 20a's plus 4. A lot of students will accidentally just think, ooh, let me distribute that exponent, and they'll write this as an answer of 25a squared minus 4, or plus 4, depending on how they feel. Either way, that is absolutely not correct. Remember to write that binomial out twice and FOIL it. We will talk about some special patterns perhaps next time that will show you a little quicker way. One last example and we'll be done with the video. Let's do example 6, where you're going to do 2m minus 3 raised to the third. Similar idea as the last one. You can't just distribute that exponent of 3. What you need to realize, guys, is that means I have the binomial 2m minus 3 as a factor 3 times. So this might remind you of the example 4, where we had the 3 binomials. Remember, we kind of attacked these two first and FOILed those together. So let's do that. 2m times 2m, 4m squared. 2m times negative 3 is a negative 6m. I'm going to have another negative 6m. And then negative 3 times negative 3 is positive 9. Over here I still have a 2m minus 3, but before I multiply that, let's add those like terms. So I have 4m squared minus 12m's plus 9, and now I got to tack on a 2m minus 3 to it and FOIL that out. I'm going to go to my color bin here and use some different colors. Hopefully this one shows up. If I'm going to multiply 4m, ooh, that's kind of a big one. I don't want to use such a thick font here. If I multiply 4m squared times 2m, that's going to be a 8m to the third. 4m squared times negative 3 is going to be minus 12m squared. Now let's move on to the second term. Negative 12m times 2m is going to be negative 24m squared. Negative 12m times negative 3 is positive 36m's. And finally, let's move on to the 9. Let's use red. If I use 9 times 2m, that's going to be positive 18m. And then 9 times negative 3 is going to be minus 27. So let's add up all the like terms. This is where you kind of have to stay organized and not rush, right? You can easily make a mistake. I only have one cubed term, and that's 8m cubed. Cross that out. I have a negative 12m squared minus a 24m squared. That's going to be a negative 36m squareds. I have a 36m plus an 18m. That's going to be what, a 54 m's. And that takes care of those guys, and then I tack on the negative 27. That's kind of on its own by itself. And there we go. Guys, I'm going to give you a couple of examples that I would like you to try and have ready for tomorrow. So these are the problems I'd like you to try. Please write them down carefully, and if you need to look back at any of the examples, make sure you do that. Be ready to share them out with your group, and let's see how well we understood the video, and we'll go over things tomorrow. Thanks for watching.